theorem, that's an existing fact. You cannot subtract from it, you cannot add to it, you just have to take it like that. So it has been established. So far we have covered factorials and permutation. So the last thing we'll be covering under mathematics of counting is combination, and that will be the last topic for this session. Now, what is combination? Unlike permutation that we said that it is an arrangement of objects in a definite order, for combination, no order is the order is not important. The order is not a necessity. So, and that's why they just say that combination is selection. When you just say, if you are picking two people from a population or from a group, the two people is still the two people, whether irrespective of the arrangement. You cannot say that because you pick Bola before Kende, so that picking or that selection is different from picking Kende before Bola. They are both humans and you are picking two people irrespective. Unlike when we are talking about permutation, which is solely arrangement of objects where the order of the arrangement matters. So for combination, order of arrangement does not matter. It's solely selection. And of course, it has its mathematical representation. Its mathematical representation is this. N combination R will give us n factorial over n minus r factorial. Obviously, you can see the old definition of n permutation R in n combination R. That is why some people represent it as this. So either way, either you represent it as n factorial over n minus r factorial, or you represent it as n permutation r over r factorial. Either way, you get your answer. So we'll just look at two examples and two of its applications, and then we can go to exercises. So now, for this example, let's quickly look into it. For example 1, we have 8 combination 3. The solution is so direct because there is an existing formula. So in this now, our n is equals to 8 and our r is equals to 3, right? So what do we have? We have 8 factorial over 8 minus 3 factorial 5 factorial. We have done this already. We know how to evaluate factorials, and so this will not give us a problem. We have 8 factorial over 8 minus 3 factorial 3 factorial, sorry. So this will give us 5 factorial 3 factorial. This can be represented as 8 times 7 times 6 times 5 factorial over 5 factorial 3 factorial, right? So 5 factorial will cancel 5 factorial. 3 factorial is same thing as 6. So 3 factorial can also cancel 6. So what do you have? You have 56. So 8 combination 3 is going to give us 56. So let's look at the second example. What does the second example say? N combination 3. In this case now, we don't know what n is. Obviously, we are expected to find n. So how do we find n? Now, you first of all represent this using the mathematical representation of combination, and that is n combination 3 will give us n factorial over n minus 3 factorial. 3 factorial is equals to what? 35. Remember the expression for n factorial. That was the first thing we discussed in this session. So n factorial can be rewritten as n in the bracket of n minus 1, n minus 2, n minus 3, and so on till 1. But here, I'll be stopping at n minus 3 factorial because I'll be stopping at n minus 3 factorial because I also have n minus 3 factorial as the denominator so that they can cancel one another. So I'll put my factorial here, and then I'll have n minus 3 factorial 3 factorial is equals to what? 35. So n minus 3 factorial will cancel n minus 3 factorial. So I'll be left with n in the bracket of n minus 1, n minus 2 over 3 factorial. Remember that 3 factorial is the same thing as 6. 6 is equals to 35. So when you cross multiply, what do you have? You have n in the bracket n minus 1, n minus 2 equals to 6 times 35. For the sake of comparison, we can say that n into bracket of n minus 1, n minus 2 is equals to what? 6 times 5 times 7. Abi? Do you agree? Do you agree? So if we rearrange this, what do we have? We have 7 times 6. If you want to follow the formation of n minus 1, n minus 2, you can see that with this formation, what do you see? There is a consistent reduction of 1 from the first number. The first number here is 7, followed by 6, followed by what? 5. So if we compare with this now, we can confidently say that your n is equals to 7, your n minus 1 is equals to 6, Abi, and your n minus 2 is equals to 5. So remember that they asked us to find them. So our n is what? Our n is what? 7. Therefore, our n equals 7. I hope that is understood. So now let's look at let's quickly look at these two questions. Question 1. Out of 7 Muslims and 15 Christians, a committee of 3 Muslims and 8 Christians is to be formed. In how many ways can this be done if there are no restrictions? So what they are saying, I told you the other time that combination is about selection, and the order of arrangement does not matter. Just pick. As soon as you pick, you are good to go. So now they want to form 7 committees. 7 committees. They needed 3 Muslims and 8 Christians. That's the goal. 3 Muslims and 8 Christians. So how do you do that? What you do is that 7 Muslims. That's the number of Muslims that you have. 7 combination. How many are you picking from 7 Muslims? You are picking 3 people, right? Yeah. So 7 combination 3. And is what? Multiplication times. How many Christians do you have? 15. 15 combination. How many people are you picking? You are picking 8 Christians. So then you solve. 7 combination 3 is 7 factorial over 7 minus 3 factorial 3 factorial times 15 combination 8 is 15 factorial over 15 minus 8 factorial 8 factorial. So with this you have 7 factorial over 4 factorial 3 factorial times 15 factorial over 7 factorial 8